In this video, we're going to examine the percent composition for a chemical compound. The percent composition of a compound is expressed by identifying the elements that make up the compound and given the mass percent of each compound. So let's illustrate this by looking at the compound methane, CH4. 1 mole of methane is composed of 1 mole of carbon atoms and 4 moles of hydrogen atoms. And we know this by looking at the chemical formula. So in order to express the percent composition, we need to express these moles as masses. So we can convert 1 mole of carbon into a mass or grams by using the molar mass of carbon, and we get a 12.0107 grams of carbon. And the 4 moles of methane, or excuse me, the 4 moles of hydrogen that make up methane, we can convert that into a mass by multiplying times the molar mass of hydrogen. And we get about 4 grams of hydrogen. So 1 mole of methane is composed of about 12 grams of carbon and 4 grams of hydrogen. But we need to present these or express these as a percentage. So we need to figure out the total mass of methane. And we do that by adding up the mass of carbon plus the 4 moles of hydrogen. And we get about 16 grams total for 1 mole of methane. So now to express it as a percent, we take the mass of each atom and we divide it by the total mass of the compound times 100. And you can see we get about 74.8% carbon and about 25.1% hydrogen. So what that tells us is that methane is composed by mass of about 74.85% carbon, and by mass, methane is made up of about 25.13% hydrogen. Another way to say that is if we had 100 grams of methane, we would have 74.8542 grams of carbon and 25.1318 grams of hydrogen. So why do we study a compound's percent composition? Well, it allows us to identify unknown compounds, which is very important in chemistry. And so knowing the percent composition allows us to calculate the compound's chemical formula. When we talk about chemical formula, there's 2 ways we can express the chemical formula of a compound. The first way, or simplest way, is what we call the empirical formula. And it tells us the simplest whole number ratio of the atoms in a given compound. The other way we can express a chemical formula is what's called the molecular formula. And this is more common. It tells us the actual number of atoms in a chemical compound. And it can be either the empirical formula or some multiple of it. So to determine if the molecular and empirical formula are the same, what we generally can do is take the ratio of the molar mass of the molecular formula and divide it by the molar mass of the empirical formula. And we get some multiple. Let me give you an example to illustrate this using a glucose. The empirical formula for glucose is CH2O. If we calculate the molar mass for this empirical formula, we get 30.026 grams per mole. Now the actual molecular formula of glucose is C6H12O6, and the molar mass of this molecular formula is about 180 grams per mole. So if we divide the molar mass of the the molecular formula by that of the empirical formula, we get a factor of 6. So what that tells us is that the molecular formula is 6 times greater than that of the empirical formula. And you can see that here. CH2O, C6H12O6, the molecular formula is 6 times that of the empirical formula. So let's look at another type of percent composition problem. Water is composed of 89% oxygen by mass and 11% hydrogen by mass. What is the empirical formula of water? And if the molar mass of water is 18.015 grams per mole, determine the molecular formula. So pause the video for just a couple of minutes and see if you can figure out a strategy to solve this problem. So the first thing we like to do is convert our percentages into grams. So let's assume we have 100 grams of our compound. If we have 100 grams of water, that tells us that we will have 89 grams of oxygen and 11 grams of hydrogen. So we just assume 100 grams, then that way we can convert our percentages directly into grams. The second step is to convert the mass of each compound into moles. So we take our 89 grams of oxygen and use the molar mass to convert that into moles. And then we take our 11 grams of hydrogen and use the molar mass of hydrogen to convert that into moles. So basically what that tells us is that our formula is H 10.913348 moles and oxygen 5.562709. But of course, a chemical formula cannot be has to be the simplest whole number ratio. So what we have to do is figure out the simplest whole number ratio to get our empirical formula. And we do that by dividing the moles of each atom by the lowest number of moles. So in this case, we have fewer moles of oxygen, so we divide the moles of oxygen by 5.562709 and the moles of hydrogen by that same number. And we do this to get the simplest whole number ratio in order to get our empirical formula. So when we do that, we get H about 1.96 and O 1. So that rounds out to about H2O, which of course is the empirical formula for water. Now we need to check to see what the molecular formula is. So like before, we need to take the molar mass of the molecular formula and we divide the molar mass of the molecular formula by the molar mass of the empirical formula to get some whole number. And then we multiply the empirical formula by that whole number. If we determine the molar mass of the empirical formula, we get 18.015, and that's the same as the molar mass of the molecular formula, which was given. So we get a factor of 1. So what that tells us is that the empirical and molecular formulas for water are the same. So let's try one more problem related to percent composition. Pause the video and see if you can solve this problem following those same steps. Okay. So we have a colorless liquid and its percent composition by mass, 84.1% carbon, 15.9% hydrogen. We're also given its the molar mass of the molecular formula. And first thing we need to do is determine the empirical formula. So let's follow those steps we talked about before. Let's assume we have 100 grams. Then we can convert our percentages into grams of carbon and hydrogen. Next, we convert our masses into moles using the molar mass of carbon and the molar mass of hydrogen. So we get about 7 moles of carbon and about 15 moles of hydrogen. So our compound is composed of carbon and hydrogen, but we need to figure out the simplest whole number ratio in order to get our empirical formula. So we're going to divide both of these moles by the smallest number, which would be the 7.00209. If we divide both of those by this to get the simplest whole number ratio, we get carbon, or C1, H2.25. Now we can't just round the 2.25 to 2. That's a little too far away to round. So what we need to do is multiply by some coefficient, the lowest coefficient, in order to get a whole number. So if I multiply the 2.25 by 4, I get 9. So I'm going to multiply both the moles of carbon and the moles of hydrogen by 4 in order to get the lowest whole number ratio. So I get C4H9. So this would be my empirical formula. The next step, we need to figure out our molecular formula. So we're going to take the ratio of our molecular formula molar mass, which is given. We're going to divide it by the molar mass of our empirical formula. So we can calculate the molar mass of C4H9. So the molar mass of C4H9, calculated to be about 57.0 grams per mole, and the actual molar mass for 114.2 grams per mole. If I divide that out, I get a factor of 2. So I'm going to multiply the empirical formula by 2. So I'm going to multiply the C4, I'm going to multiply that times 2, and the H9 by 2. And I get a molecular formula of C8H18. So be sure that you understand the rationale behind solving these percent composition problems and the terminology, and be sure you're proficient at it.